this project is known as app behavior analysis. In this project, I needed to analyze the data for a fintech company and create a model which could predict if the users of the app of the fintech company will enroll for the premium membership of the app or no. The datasets which were provided by the fintech company were two. This was the first dataset that they provided. It contained information like the user ID, the date they first opened the app, the day of the week when they first opened the app, the time, age of the users, the screen that they visited, the number of screens that they visited. There is a mini game in the app, whether they played that or no, if they used the premium features or no, if they enrolled for the premium features or no, the date when they enrolled for the premium features, and if they liked it or no. Another dataset which was provided contained information for the top screens. This was the list which was there. Python scripts were written for this project. Two Python scripts were written, as you can see over here. The first one was a basic EDA script, and after end of that script, the data was cleaned and the clean dataset was saved, which was used to then build the model. Let's discuss the EDA script first. After importing the libraries, the datasets were imported and basic data exploration was performed. After data exploration, EDA was started and certain plots were created to see if there were any irregularities in the dataset which need to be dealt with. After that was done, feature engineering was performed. We needed to decide a time as to till when will we consider if the person had enrolled for or the premium membership or no. To do this, certain graphs were performed and a timeline was decided. As you can see in this graph, majority of the people enrolled within the first 20 hours. Thus, to give a bit of more time, a deadline of 2 days or 48 hours was decided, and anyone who enrolled after that was removed. After that, the second data set, that is the top screens, was imported. Separate columns were then created in the primary data set, and the screens that the user visited were identified. During exploring the dataset which was just created, it was seen that certain funnels were there. Like consider inside the savings funnel, there was savings 1, savings 2, and a lot of columns, as you can see over there. Thus, these funnels were removed and a single savings column was created. This was done for the credit. This was done for the credit, the credit card, and the loan as well. And after that, the dataset was just seen again and to see if all the functions were performed properly or no. This clean dataset was then saved. Let's come to the model building part now. After importing the libraries, the clean dataset was imported. This was followed by basic data exploration. After exploring the data, the dependent and the independent variables were created and the model building process was started. The training and test sets were created. As we needed the user ID to identify if the predicted results were proper or no, they were firstly only saved inside a different variable. Feature scaling was performed. Logistic regression with L1 regularization was used to build this model. Over here, the model was built and the predictions were made. The accuracy and other matrices were checked over a year, followed by building the confusion matrix. K-fold cross-validation was used to verify the accuracy. After that, the coefficients were analyzed to see how the coefficients affected the results. This was followed by improving the model by using parameter learning, that is grid search. The parameters that were given were then refed to the model and an L2 logistic regression model was then built. The predictions were then made. The results were checked and K-fold accuracy was used again to verify the results, and at the end the final data set was built containing the user ID, the original results as to a member enrolled or no, and the predicted results for the model.